All right, so hi everyone. Thank you for joining and thank you for having me here. My name is Dimitrios. I'm from Greece. Here are a few things about me. So I'm engaged in computer security since 2002. I was a member of one of the first reverse engineering groups back in Greece, and I started my career as a network security engineer for about 10 years. Then I moved into developing for almost 5 years. And the last 7 years, I focused mainly on mobile security, while before I joined Microsoft's threat intelligence team as a senior security researcher, I was leading another team which was conducting malware reviews for the Google Play Store. Besides that, I'm a father of two, a boy and a girl, and in my free time I write and play music. So with that said, and hopefully you didn't come here to hear about how to exploit Windows, let's jump into the outline of this presentation. And before we start, I just want to make clear that this is a follow-up of a previous talk, which was given about 8 months ago at Black Hat Europe. However, since I'm sure that many of you didn't have the chance to watch this talk, I'm going to include a short summary of it. So with that said, we're going to start with some basic theory concepts regarding class loaders, and then we're going to revisit the exploitation techniques that I already demonstrated in my previous talk. Why this follow-up? What are the new insights that suggest further digging or even a readjustment of what has been said so far? And after establishing this context, we're going to move to the main part of this presentation, where I'm going to demonstrate to you a new exploitation technique. I'm going to include a live demo, although I don't usually do that. And with that said, we're going to conclude with some takeaways and the Q&A session, if there are questions, of course. All right, so a few things about class loaders. Class loaders are an essential part of the Java virtual machine, and they are used to find binary representations of classes, interfaces, and when these are found, the JVM loads them into the application's memory. We have various types of class loaders, like primary ones, like the Bootstrap, which is responsible to find Java core libraries. And we have also secondary ones like extension or application class loaders, which are used to find and load, better say, secondary classes from extension or application directories, as their name implies. When it comes to loading a class loader follow a delegation model, according to which the secondary ones refer to their parents in case they themselves were not able to locate a class. And this will finally end up to a class successfully loaded, or to a class that was not found, to a well-known exception, class not found. Alright, so let's now move to Android. Android used the Dalvik VM, which was initially adopted in order to address some of the JVM's limitations. The Dalvik VM then was replaced by the Android runtime. Despite though this shift, the whole Android application development deployment didn't change much through all these years. Now, when it comes to class loaders in the Android operating system, some primary ones are the boot class loader, which once again used in order to load primary classes. And we have the PathClassLoader or the DexClassLoader, which, for example, DexClassLoader or the in-memory DexClassLoader are used for dynamic code loading and so on. All right, now let's move to serialization and parcelables when it comes to Android. Serialization in Java, I guess it's well known to almost everyone, is the process of converting an object into a byte stream in order to transfer this object across different JVMs, either locally or across a network. Now, for this process to be successful, the receiving end must include the class of this object to its class path. Now, when it comes to parcelables, Android had to introduce parcelables for better efficiency due to the fact that moving objects in Android is very common between components. So Android uses parcelables besides serializables for these reasons, and classes that are parcelables must implement the parcelable interface, as well as the create from parcel method for the serialization. This is actually a way to identify when a class is parcelable, so we can create objects that we can send from one app to another. All right, so some common issues, some known issues basically when it comes to serialization and parcels. Serialization can introduce vulnerabilities by the time that the serialization source can't be controlled by an attacker. actually MITRE assigned more than 690 CVEs for this kind of issues over the past 2 decades. And for prominent object-oriented languages like Python, .NET, Java, and so on. However, Android's minimum reliance on Java vulnerable classes has raised the bar when it comes to exploiting this kind of issues. But Android also is not immune to this kind of attacks, and here are some notable CVEs. So the first one, regarding serializables, was discovered in 2014 by Jan Horn, who proved that the object to be deserialized was not inspected if it was actually belonged to serializable class. So what with that? So this way he was able to serialize objects of any class, and subsequently he was able to, by doing that, by serializing a specific class, he was able to get control of an 18 pointer during the garbage collection process and get arbitrary code execution with system privileges. A year after, Pelez and Hay, they paper one class to rule them all, something similar. In this case, they they exploited this class here, a non-transit field of this class, and once again managed to get arbitrary code execution with system privileges. Now let's move to parcellables, which are also not immune to this kind of attacks. There's a whole class of vulnerabilities which stems out from the mismatch between the read from and write to parcel. And the first most important one was discovered in 2017 by Mikhail Bernarski, who by exploiting it, he was able to get what we call lunch anywhere. So he was able to send intents that he was creating with system privileges. A few years after, the same researcher, same type of vulnerability. However, in this case, he was able to get arbitrary code execution with system privileges. So it seems that the researcher community, as well as the developer community, is aware of issues which may occur when we handle these kind of objects in an insecure manner. Now, there seems though to be a misconception when it comes to custom classes, custom objects. And what I mean by custom classes, I'm referring to the ones which are declared within an app. We can't find them in some kind of a public repository, library or something. We can't basically import them to our project. So basically due to the fact that, the fact that Android applications are sandboxed, so this creates the misconception that one application cannot interfere with another application's class loader, can create objects that belongs to classes that are declared to other apps. However, the fact that one application may be designed to receive these objects from within its exported components or from intents that may originate from other apps can lead to serious security issues. To be more specific, imagine that we have a parcel that contains a URL, actually this is very common, contains a URL that this application uses to send authenticated requests, or an intent that this application uses to send with its own ID. So if this parcel, if this data is sent by a trusted entity, this, as you understand, can lead to serious issues. Now let's go through, very quick I promise, the exploitation technique that I already demonstrated in my previous talk. So basically we're going to see how efficient ways in order to create objects that belong to classes that are declared in other apps. And the most obvious, I guess, way is to simply reconstruct the whole class. And how we do that, imagine that we have this case here, this class, so we can simply reconstruct the package within our own project, Android Studio for example. Then we can copy and paste the decompiled code once again in our project and start creating instances of this class. So it's pretty much trivial. However, and this works well, however for small size classes. Imagine now that we have this kind of class, ignore the fact that it's abstract. So imagine that we have this class which has another class as field, that class has another one, and this one has another one, and so on. So this, as you understand, creates some kind of complexity which we can't reproduce, right? We can't copy and paste all these classes within our project. So the next way to do such a thing, to create this kind of objects, the easiest way, I guess, is to get the dex file or the APK file for which you want to create this object. Use a tool like dex2jar in order to create a jar file out of these dex or APK files, and finally import these files to Android Studio, for example. This works for any size of class. However, it has two main disadvantages. Obviously, the size, since we have to include an additional APK to our app. And if we ignore that, the most discouraging, I would say, issue is the fact that we might have collisions between the classes that we are importing and the class that we have in our project. So we have to exclude all these classes manually, which is a process which is very painful and renders this technique also impractical in many cases. Last exploitation technique, when it comes to the one I already presented, has to do with class loaders and the reflection when it comes to Java. So basically consists of three steps. We borrow the class loader from the target. We use reflection in order to create instances, classes actually, and instances of these classes, and finally send the instances to the target. How we do that? We use the create package context for convenience, I will say, with some specific flags which allow us to do such a thing. And then we use some generic code in order to create this kind of instances. So this code actually takes the name of the class, the kind of the fields of the class, some data that we use for initialization, and returns instances of this class. Alright, so that's it. I guess when it comes to exploitation techniques that I already presented, let's summarize them to have a general picture. First of all, class reconstruction works well for small size classes. It is, though, impractical even for medium sized ones. The second one is to import an APK as a library, which works well for any size of class. However, it has as main disadvantage the fact that we might have collisions between the classes that we are importing and the class that we have already in our project. And finally, dynamic code loading, which works well even up to medium sized classes. However, it has an issue. I wouldn't say an issue. I mean, a disadvantage, I would say, which is the package visibility, which we're importing in Android 11. These can be, I mean, we can overcome this kind of issue very easy, but I'm not going to go into details. Whoever wants to get into details about this, how we can do that, can refer to my previous talk. Alright, so let's summarize what we have so far, this first part. So Android uses parcellables besides serializables for inner and inter-process communication. So in several cases, Android applications try to get these objects from intents that may originate from other apps. And actually this is, once again, just to highlight that, is very, very common. We saw already various exploitation techniques, how we can actually create these kind of objects and send them to the targets. So what stands out from what we said so far is that we can indeed create these kind of objects for small to medium sized classes. However, what happens when we have larger sizes, right? Large classes. So what happens in this case? Do any of these techniques apply? And the truth is that none of these techniques actually can be used for this kind of classes. And I learned that the hard way after I had a talk with a friend of mine who simply asked me to create an instance of this master class here. So this is a parcelable class, apparently, which is decompiled using JDEX. Now, if you count the fields of this class, we're going to see that it has 46 fields, out of which 9 are custom classes. So in the beginning, I said, okay, let's give it a try. Let's try to recreate this class. However, if you dig deeper, you're going to see that these 9 classes have additional ones, additional fields, and so on, and so on. And you're going to reach the number of, let's see, it was, 90 fields that you have to initialize in order to create an object of this class. It's not always that we have to initialize all the fields, right? Because some of them may be null, but let's say the best case scenario, you might have to initialize something like 50, which once again, it doesn't make much sense to do such a thing. Alright, so how we tackle these kind of cases, how we can create instances of these classes. So if you think about it, as I said before, if we want to exploit an app, right, in most of the cases we want to change a specific value. For example, a URL, as I said before, or an intent, or some kind of a value which the app might mishandle, right? So what about if we trigger the creation of the parcelable from the target, intercept this object somehow, store it, revive it, modify it, and send it to the target? So let's see that in practice so you understand, I mean, to visualize that better. So usually we have the target, an app, right? And we are, let's say, the attacker, which is another app, a malicious app. So usually we have an app which has an activity A that creates an intent and send it to activity B, right? So this intent may, once again, have some kind of a parcelable or serializable. The idea is to intercept this intent, right? And by the time, of course, that the activity B is modified values, and by the time that the activity B is exported, send it to activity B and see how the target will handle this, let's say, malicious values. So apparently, the first step is pretty much trivial to how we can intercept this object, and we can do that with a simple Frida script, like the one that I have here, which hooks the start activity method and simply changes the target component of the intent. I already integrated that in my project in Medusa, where you can simply type redirect and change the target of a specific intent. So that's easy. How we can now modify these values? Assuming that we receive this intent, this our intent, then we do some basic checks to see if it actually contains the parcelable that we are interested about. And the most important step here is to set the class loader of the extras of this intent, the class loader of the target. How we do that? We can use once again, the create package context in order to get the class loader of the other app. Some additional checks. And finally, here we can isolate the field that we are interested to modify using reflection and write the parcel as a file. How we can write the parcel as a file? So we can use, first of all, we have to create a parcel, and in order to create a parcel, you can't use the default constructor of the parcel class due to the fact that this is private, intentionally private. But you can use the obtain method of the parcel class in order to do such a thing. Then we use the write to parcel method of the parcelable. Once again, we got the parcelable. We can use now the write to parcel in order to initialize this new parcel that we created with the data that we already have, right? Or we modified. Finally, we can use the marshal method of the parcel class in order to create a byte array using this parcel, this new parcel. And finally, of course, write it as a file. Now, how we can revive it? Once again, we can open the file, of course, get the byte array out of it, and finally use the parcel.obtain method once again. Now we are using the unmarshaled method in order to create, in order to initialize this parcel using the data that we have. And finally, we use the create from parcel method of the parcelable class in order to create the parcelable object. I can kind of confuse you with parcelables and parcels. Anyway, I'm going to, I hope it will clear everything now with a demo that I'm going to demonstrate to you. Alright, so let me first introduce you the target. So here we have an app, right, which has a parcelable class. This class has two fields. It's not a master class like the one that I showed you so far. However, the same principles, they say apply. So it has an intent and a string, right? Two fields. Now we have, here's the issue. We have activity A, which is exported. So this activity A creates an intent, a new intent. It checks the current intent if it has a parcelable, which is called notification, right? If it has such a thing, it will set it as an extra to this intent too. If it doesn't have such a thing, then it will create a new parcelable. It will set the fields. Imagine you have an intent and a URL. So it will set the fields. And finally use the start activity in order to send this intent. Can anyone figure out what is the issue here? Yep.
So the issue is that this activity is exported, doesn't check the
You can't check the sender when it comes to intents. You can check when it's a pending intent, you get the caller, but you can't check, yeah. You can't do that. Actually so first of all, just to make clear, this code snippet that you see here might be simple, it looks simple right now. However, it's a simplified case of a very, very common issue, which you are going to see in many apps. If you are, reversing Android application is very, very common. Alright, anyone else want to give it a try? Okay, that's close to what you said, right? But, this is not the fix. You can't check if the sender is actually that. The sender has to include something, right? Except if it is a pending intent. So this code is vulnerable, let's say by nature, how to explain it. So, we shouldn't get the parcelable from the current intent, right? Because this parcelable, might originate from another app, right? In any case, we shouldn't do that. That's the whole point. Alright. So now, what is the issue here? So this intent will go to this activity B, which is not exported. However, this activity B will extract the parcel, the notification parcel. Then from this parcel we'll get the intent. It will isolate the data part and append as a query parameter the user's token and send this intent to the default browser. Once again, this is very common, right? So they get the data part, append as a query parameter the user token, and send it for some kind of a single sign-on or something. Alright. And let's try. Let's see how this works. Hopefully it works. Okay. Alright. So this is our attacking app, right? So yeah, it's kind of hard to see there. Yeah. Okay, initially we have the files directory where we're supposed to save the specific parcelable, right? The one that I told you about so far. So we have our attacker, then we have let's say our victim app, which is this one here. So how this works, this once again sends an intent, and the activity B takes this intent and send it to the default browser. That's, like I said, once again, very common. Let's see how this actually works. All right. Okay, so we see, let's go from here. So you see that the main activity sends an intent to activity B. We can see here that it has a parcelable, right, which is called notification, and this parcelable is received by activity 2. The activity 2 unmarshals this and gets the intent out of it and send it to, it's a view intent, so it will send it to the default browser, which has the user token. Alright, so let's now try at least to redirect. So initial activity destination is, I guess, this one. The new destination is it's kind of hard to do like that. Anyway, and finally we have here all right. I hope I didn't. All right. So now let's see what will happen. Hopefully. So this will send the intent, and now this intent due to the fact that we redirected, it will go to our app, right? So now our app supposed to have this saved, yeah. So this is the parcelable, right? Which we store in our files folder. All right, so okay. This intent now contains the data that we already changed. So as I showed you before, the target will get now the parcelable from our app, right? And now when it will send the intent, it will go to the app, I mean to the URL that we already changed, the one that modified. Okay? All right. So that was it. Let's okay. All right. And with that, we concluded this session. And when it comes to takeaways, so we saw multiple ways in order to, let's say, create objects that belongs to other classes, right? To classes that are declared in other apps, basically. So, scaling from small size classes up to monster size ones, like the one that I showcased in this briefing. Now, which one is better to use? I would say that it depends on the case. However, using the third exploitation technique that I demonstrated in my previous talk, as well as this one here, you can cover almost all the possible vulnerability cases. Now, the next one, I already mentioned that. However, I want to stress this out. It is a very common issue. Maybe it is due to the fact that this sandbox misconception creates, like I said, this sandbox issue thing creates the misconception that apps are protected somehow, or maybe due to the fact that these kind of issues are sometimes buried under multiple layers of, let's say, inheritance or abstraction when it comes to Java. I don't want to put the blame on the developers when it comes to this kind of issues. We all know that developing is quite a complex process and may introduce serious issues. However, I encounter a lot of cases where this was pretty much obvious. In these cases, the developers were either clueless about what this can happen, or they didn't care much, I guess. Anyway, so this is why we are here. And last but not least thing that I want to mention, and this is something that I mention in almost every talk that I have. So you noticed that this issue requires a third-party app to be installed on the same device with our target to perform the exploitation. So this perceived safety of an attacker who has to convince the victim to install an Android app in order to do such a thing has at some point to come to an end. So it is a part of my job to perform malware research when it comes to Android apps almost daily, and either of market, even market apps or whatever. So we are seeing every day several developer accounts which are banned because they publish something which is harmful, right? This almost 2.4 million apps were banned in a time span of 1 year only from Google Play Store. So you understand, I mean, the problem is huge. And the idea is here is if we close our eyes and say that these things cannot happen, or we acknowledge them and fix them. All right. And with that said, that was it. Thank you very much. If you have any questions, I'm here to answer.